So let's talk about the effects of sample size and sample variance on the power of our independent samples t-test. The first question is, what happens if sample size changes? Well, what we need to think about here is if the sample size goes up, we got to think about how we're calculating t. And when we look at t, right, it's the difference in the two means divided by the standard error. Well, the standard error of the standard deviation of the distribution of the means. So the standard error, the denominator of the standard error is sample size. So as the sample sizes get larger, right, we would expect as the sample size gets larger, we would expect the standard error itself to get smaller, right? Because when the denominator of a fraction gets bigger, the value of that fraction gets smaller. So the standard error actually gets smaller as we have a larger sample size, even if the standard deviation of the sample doesn't change. And then, because now the denominator of our t calculation is getting smaller, t itself actually gets larger given the same difference between these two sample means. What this means is that t will be more extreme when our sample size goes up, which means that it is easier to get a significant result. And degrees of freedom absolutely plays a role here, but the underlying idea here is still the same. It's easier to get a statistically significant result as sample size goes up. As sample size go down, the opposite happens, right? Our standard error goes up, and so our t statistic goes down for the same means and sample standard deviations. So all else being equal, when the sample size goes up, the t statistic itself will go down. It'll be less extreme, which means it is less likely to actually detect something. So when we have a larger sample size, we have a more powerful and more sensitive test. When we have a less of a sample size, when it goes down, we have a less powerful or less sensitive test. Now, variance, very much the same way. If our sample size stays the same and our mean difference stays the same, a larger variance means a larger standard error, which then means a smaller, less extreme t. This is then less powerful. If there's a smaller variance in our samples, then we have a smaller standard error and now a more extreme t. And I guess I could have included in here, if the mean itself is bigger, the effect side, there's a larger difference between the means, then that's also easier to detect. And so we want to look at, I guess the takeaway here is that you want to look at the actual formula for t to look at how differences between means, how differences in variance, and how differences in sample sizes are all going to affect our likelihood of finding statistical significance, all else being equal.